Okay, today's lesson is 38, using properties of equality to solve equations. What's our objective? Get ready?
Using properties of equality to solve equations.
Good. Today we're going to focus on inverse operations to isolate a variable. So an inverse operation, what is it? Ready?
Inverse operation.
Inverse operation is the opposite of one of our operations. So the opposite of adding is subtracting. So the opposite of multiplying is dividing. So let's ask the question, what's the inverse operation of division? Think. Get ready?
Multiplication.
Multiplication, good. What's the inverse operation of subtraction? Think. Get ready?
Addition.
Addition. So knowing that, we're going to use inverses so that we can undo an operation so that we can isolate a variable. So we're going to talk, I'm going to just mute that for a second. We're going to redirect our attention to this triple beam balance. I'm going to try to do this a little faster than I did in my other classes. I'm going to add a mystery weight on the left side. Okay, I don't know how heavy it is, but just for fun, I'm going to put in an additional 100 grams of weight. So if I were going to find out the weight, already I know to balance the left side, I'm going to have to slide the slider over at least 100 grams. So let's start with that 100. So I've got 100 and 100, but I need to do a little bit more weight to find out how much my cards are. And some of you are going, why don't you just put the cards on and weigh it? Because it's not as much fun, and it won't illustrate what I'm trying to illustrate. So we're going to slide over and see 50, 60, 70, 80, 90. Let's see, make sure I got these centered. 90's not enough. 100's too much. Okay, so we're going to go back to 90. We're going to use the small slider, and Addie's going to help give me a readout when it's balanced. What is it, Addie? Can you read that? I got 100 plus, is that 90? And then how many is that one? 1.5-ish?
No, more like 1 point.
Almost 2?
Yeah.
Can we round it to 2? So it was 100 plus we had the 90 and plus 2. So really this is 192. Okay. Well, if I want to now find out what my mystery deck of cards weighed, couldn't I take off the 100 off of this side? And couldn't I slide the 100 back over? Because I'd have to keep them balanced. So if I took off 100 here, 100 here, what's my, did I get that over? And is it balanced? What do you got, Addie?
You have 92.
Okay, so I took 100 off of both, and I ended up with my mystery weight of 92, which I could have weighed by itself in the first place. But I wanted you to see, to keep the balance of the left side and the right side, if I add weight to one side, I have to add weight to the other side. If I remove weight from one side, I have to remove weight from the other side. Give me a nod if that makes sense. Okay, that's how we're going to balance equations. What is it called? Get ready?
Balance equations.
Balance equations. I'm going to leave it at that example. I'm going to have you hit pause because... Okay, so now we're going to do a couple of scenarios. So here's my weight scenario. I've got a mystery weight plus 5 grams. And on this side of the scale, I've got 7 and a 1 and a 4. So if I wanted to isolate x, I'd have to remove the 5 and get rid of it, like take it off. So then I found on this side, hey, let me take off the same 5 grams or 5 pounds, whatever it is. Let's get rid of that as well. That would isolate, gone, gone. X would have to equal 7, because that's the only way to keep it balanced. So what if we do it without the weights? We have to isolate x. How do we isolate x? We look at what operation is being done to the x. Has something added onto the x? Well, if it's being added, we would do the inverse operation or subtract. If it's being multiplied, we would do the inverse operation or divide, because it would undo it and it would isolate x. So let's do this. Properties of equality. If two things equal each other, if I add something to the left side, I need to add it to the right side. If I subtract it from the left side, I should subtract it from the right side. If I times something on the left side, like times c, I should also times it on the right side. It's still equal. If I divide both sides, is it still equal? Yes. So I have to do it to both sides in the same way, same operation, same number, to keep the equality, to keep a balanced equation. So now let's get to the fun stuff, solving an equation. This is like a 5th or 6th grade problem, right? So today I'm not teaching you how to solve, I'm not teaching you, let's find the answer like we did in 5th grade. I'm going to teach you how to solve it using inverse operations, keeping a balanced equation, and I'm going to show you the way I want you to write it. This is the way they write it in Japan, in China, Norway, Brazil, Argentina, Mexico, London, or England. Everywhere in the world, this is the math they use. When you high school, all of your high school teachers, your chemistry teacher, your physics teacher, your math teachers, this is the way they will write it. So it's a new way for some of you. You'll say, that's a lot of writing. Yes, that's just the way you're going to do it from now on. So this is a scale. Picture this as a big teeter-totter, right? I gotta isolate 11, so I want to get rid of 11. Well, 11 was added on, so the opposite of addition is, get ready?
Subtraction.
Subtraction, very good, you're listening, thank you. So if I subtract it from the left side, I also subtract it from the right side, and I write that underneath it, I draw a line. I write it underneath it, I draw a line, and I put the sign so I know what I did. Well, plus 11 minus 11 equals 0. That's why I did it, because I want it to go away. I copy my x down, I copy my equal sign down, and then I just go ahead and do the arithmetic. 2 minus 7, that'd be 21, and I box my answer. So I wrote my steps and I showed a vertical process. Let's do one that has a subtraction. X minus 2.3 equals 5.70. So I look, what is the 2.3, what's it doing to the x? What operation is happening here? Think. Bo.
So what we're doing is we're subtracting it from, so I gotta figure out how to do this because I'm not.
But you're right.
X, we're subtracting
Mm-hmm.
2.30 to get 5.7.
Exactly. So that's the key. Start with what's happening. Well, this number is subtracting. What's the opposite of subtraction? Get ready?
Addition.
Addition. So to undo it, we put the same exact number, but we do the opposite arithmetic operation. The opposite operation. We do it to both sides to keep a balanced equation. Minus 2.30 plus 2.30, 30 is 0. That's why we did it. In x, we copy it down. We copy down our equal sign. We add this. That gives us $8. Throw on our units, label, and we're done. Give me a thumbs up if so far it makes sense. Okay, good. This is kind of the same operations you've done. It's just a new way to write it, so it looks different. All right, how would we write this one? Well, I would know 12 times some number equals this. So in your mind, you're thinking, well, how to just divide? We're going to. But I first say, what operation is going on here? What's this operation? Get ready?
Multiplication.
Multiplication. What's the opposite or inverse operation of multiplication? Get ready?
Division.
Division. So to undo the 12 times, I'm going to divide. If I do it to the left side, I should also do it to the right side. The 12s turn into 1. That question someone asked earlier, why? There's a 1 left over when they cancel. 12 over 12 equals 1. So it's 1 times m. I don't need to write the 1 though. And then I copy my equal sign right underneath. I write my m right underneath. And then I divide that. And I have this memorized from the last class just to save calculation time. We get 70 cents. All right. You guys, I'm going to call on some students. What operation is happening right here? Kaylee. Multiplication. What's the opposite of multiplication, Lexi?
Division.
Division. So what are we going to divide, Weston?
3.4.
Say it one more time.
2, 3,
2 thirds?
2 thirds,
Okay. So we're going to divide 2 thirds. And then what do we write over here?
3, 4.
No. If I do it to the left side, I have to do the same exact
Oh,
thing.
probably
2 thirds. All right. So I could now, these cancel, W's alone, and I'm going to copy, dot, flip. But Lexi sees another way we could do it.
So my teacher last year said even though you're canceling it out, you multiply by its reciprocal
because what you do to one side, you do to the other.
Wait,
So,
reciprocal, why would you multiply by the reciprocal, Lexi? What would that do?
because it's division with fractions.
It's
And
division with
It
fractions.
makes it cancel out.
The 3 over 3 turns into 1. The 2 over 2 turns into 1. So really I have 1 times w, which is just w. It still worked because w is isolated. Then over here, I'm going to go 3 times, it's like it's already flipped for me. 4 times 2 is 8. So Weston was right and Lexi was right. 2 different ways you can pick the way that you like better. And we don't have to change it into a mixed number. It's totally fine in this course. Lexi.
So my teacher last year said he had like a thing for it where you say marker spot look to the, or that's rounded, but you say what's indicated and then you do the opposite and then what you do to one side, you do to the other. And then
I like the word what's
how-
indicated. And then you'd say multiplication. What's the opposite? Division. So you divide both sides. In this case, we did the reciprocal, which did the same thing. Okay, good. Does it matter if the x's are on the left side or the right side? It's still equal, so whether or not I have the x on the left side or everything's reversed, they're still equal. I can do the same operations, and you'll see in this case. The x is now on the right side. Do I still want to isolate x? Yes. So let's look. What operation is indicated? What operation is this? Get ready?
Subtraction.
Subtraction. What's the opposite of subtraction? Get ready?
Addition.
Addition. So to isolate x, I'm going to do the opposite. Use the same number. If I do it to the right side, I have to do it to the left side. Now I add. Negative 2.3 plus 2.3 is 0. It's gone. I just throw a slash to show it. I copy my equal sign down. I copy my x down. And then here I add 3.8. Box my answer. Thumbs up if it makes sense so far. Okay. And our whiteboards are put away. Our textbooks are closed. And your eyes are up front. Hey, here's the bonus question. This is going to take a little bit of thinking because it's different. So I want to challenge you. Write this down in your notes. This is a different one. And it has everything to do with that negative being on this side of the x. Solve it as best as you can. And put your pencil up when you've got it. Check your answer. Okay, so I walked around, I saw a lot of 16s. I saw a negative 16 or 2, and I saw 12s and negative 12s, and I saw some other weird numbers that were weird. But okay, we got to isolate x. So I have to get rid of the 2, and we decided that the 2 was positive. So what's the opposite of a positive 2, Samantha?
Subtraction.
Subtraction. So if I subtracted a 2 from a 2, that would make this go away, right? So if I do it to that side, I have to do it to this side. A positive 2 minus a 2 is 0. 14 minus 2 is 12. Look how I'm copying everything down just because I gotta keep everything organized and teaching you how to write this. And then, wait a minute, I don't want negative x, I want regular x. How do I get rid of a negative there? Hannah? You should just move it over to that side? Kinda. Let's do the math operation. It's got a negative 1 times x, right? That's my coefficient, it's a 1. So if I don't want it there, can I divide it out? Get rid of it? So if I do it to the right side, do it to the left side, the negative divided by the negative makes it positive. I'm left with x, a positive x. That's what I wanted, and 12 divided by negative 1 is negative 12. All right, so yeah, that might have been a little bit tricky for some of you. Did it make sense? Give me a nod if, yeah, okay, makes sense. So these are kind of new problems. Good for course 3, we learned something new today. Rachel, you have another way.
Explain that again.
Explain. Okay, so the 2 is a positive 2.
Okay.
Could you say that it's being added to the negative x? If I rewrote it and said negative x plus 2, does it mean the same thing? Yeah. If it was like 8 plus 6, I could say 6 plus 8. If this was negative, I could say that, right? So that's all I did if I switched the order. So I guess what we're saying is the 2 is being added, so to get rid of it, I subtract it. Okay? So if I subtract it from the right, also subtract it from the left, that made it eliminate. 14 minus 2 is 12, and copy down your negative x. Well, we don't want negative x. The shortcut is just go like this. Beep. That's the shortcut. Okay? So if that makes it seem simpler, there you go. Okay, any other questions? All right, let's do a practice set. We're on 254, and you've got D, E, F, and G.